formation and type of precipitation. Real-world reading link. Section 11.3. Clouds and precipitation. Clouds vary in shape, size, height of formation, and type of precipitation. Real-world reading link. If you look up at the sky, you might notice differences among the clouds from day to day and hour to hour. Some clouds signal fair weather, and others signal violent storms. Cloud formation. A cloud can form when a rising air mass cools. Recall that Earth's surface heats and cools by different amounts in different places. This uneven heating and cooling of the surface causes air masses near the surface to warm and cool. As an air mass is heated, it becomes less dense than the cooler air around it. This causes the warmer air mass to be pushed upward by the denser, cooler air. However, as the warm air mass rises, it expands and cools adiabatically. The cooling of an air mass as it rises can cause water vapor in the air mass to condense. Recall that the lifted condensation level is the height at which condensation of water vapor occurs in an air mass. When a rising air mass reaches the lifted condensation level, water vapor condenses around condensation nuclei, as shown in Figure 11.17. A condensation nucleus is a small particle in the atmosphere around which water droplets can form. These particles are usually less than about 0.001 millimeter in diameter and can be made of ice, salt, dust, and other materials. The droplets that form can be liquid water or ice, depending on the surrounding temperature. When the number of these droplets is large enough, a cloud is visible. Atmospheric stability. As an air mass rises, it cools. However, the air mass will continue to rise as long as it is warmer than the surrounding air. Under some conditions, an air mass that has started to rise sinks back to its original position. When this happens, the air is considered stable because it resists rising. The stability of air masses determines the type of clouds that form and the associated weather patterns. Stable air. The stability of an air mass depends on how the temperature of the air mass changes relative to the atmosphere. The air temperature near Earth's surface decreases with altitude. As a result, the atmosphere becomes cooler as the air mass rises. At the same time, the rising air mass is also becoming cooler. Suppose that the temperature of the atmosphere decreases more slowly with increasing altitude than does the temperature of the rising air mass. Then the rising air mass will cool more quickly than the atmosphere. The air mass will finally reach an altitude at which it is colder than the atmosphere. It will then sink back to the altitude at which its density is the same as the atmosphere, as shown in Figure 11.18. Because the air mass stops rising and sinks downward, it is stable. Fair weather clouds form under stable conditions. Reading check. Describe the factors that affect the stability of air. Unstable air. Suppose that the temperature of the surrounding air cools faster than the temperature of the rising air mass. Then the air mass will always be less dense than the surrounding air. As a result, the air mass will continue to rise, as shown in Figure 11.18. The atmosphere is then considered to be unstable. Unstable conditions can produce the types of clouds associated with thunderstorms.
Figure 18. Stable air has a tendency to resist movement. Unstable air does not resist vertical displacement. When the temperature of a mass of air is greater than the temperature of the surrounding air, the air mass will rise. When the temperature of the surrounding air is greater than that of the air mass, it sinks.
Atmospheric lifting. Clouds can form when moist air rises, expands, and cools. Air rises when it is heated and becomes warmer than the surrounding air. This process is known as convective lifting. Clouds can also form when air is forced upward or lifted by mechanical processes. Two of these processes are orographic lifting and convergence. Orographic lifting. Clouds can form when air is forced to rise over elevated land or other topographic barriers. This can happen, for example, when an air mass approaches a mountain range. Orographic lifting occurs when an air mass is forced to rise over a topographic barrier, as shown in Figure 1119. The rising air mass expands and cools, with water droplets condensing when the temperature falls below the dew point. Many of the rainiest places on Earth are located on the windward sides of mountain slopes, such as the coastal side of the Sierra Nevadas. The formation of clouds and the resulting heavy precipitation along the west coast of Canada are also primarily due to orographic lifting. Convergence. Air can be lifted by convergence, which occurs when air flows into the same area from different directions. Then some of the air is forced upward. This process is even more pronounced when air masses at different temperatures collide. When a warm air mass and a cooler air mass collide, the warmer, less dense air is forced upward over the denser, cooler air. As the warm air rises, it cools adiabatically. If the rising air cools to the dew point temperature, then water vapor can condense on condensation nuclei and form a cloud. This cloud formation mechanism is common at middle latitudes where severe storm systems form along the cold polar front. Convergence also occurs near the equator, where the trade winds meet at the intertropical convergence zone. You will read more about these topics in Chapter 12. Types of clouds. You have probably noticed that clouds have different shapes. Some clouds look like puffy cotton balls, while others have a thin, feathery appearance. These differences in cloud shape are due to differences in the processes that cause clouds to form. Cloud formation can also take place at different altitudes, sometimes even right at Earth's surface, in which case the cloud is known as fog. Clouds are generally classified according to a system developed in 1803, and only minor changes have been made since it was first introduced. Figure 1120 shows the different types of clouds. This system classifies clouds by the altitudes at which they form and by their shapes. There are 4 classes of clouds based on the altitudes at which they form: low, middle, and high. In addition, there are clouds with vertical development. Low clouds typically form below 2,000 meters. Middle clouds form mainly between 2,000 meters and 6,000 meters. High clouds form above 6,000 meters. Unlike the other 3 classes of clouds, those with vertical development can form at all altitudes.
The cirrus, the cirrostratus, the cirrocumulus, the cumulonimbus, the altocumulus, altostratus, the cumulus, the stratus, stratocumulus, and the nimbostratus.
Low clouds. Imagine a warm summer afternoon. The sun is beating down, heating Earth's surface. In areas where the heating is particularly intense, such as fields with dark soil, conduction causes air above the surface to become warmer than the surrounding air. As the temperature rises, the air expands. its density becomes lower than that of surrounding air, and it begins to rise and cool by further expansion. When it reaches its LCL, it becomes saturated, and the water vapor it contains condenses into water droplets. These droplets eventually become numerous enough to form a visible cloud. If the air stays warmer than the surrounding air, the cloud will continue to grow. If the air does not stay warmer than the surrounding air, the cloud will flatten out, and winds will spread it horizontally into stratocumulus or layered cumulus clouds. Another type of low cloud that forms at heights below 2,000 meters is a stratus, a layered cloud that covers much or all of the sky in a given area. Stratus clouds often form when fog lifts away from Earth's surface. Middle clouds. Altocumulus and altostratus clouds, which form at heights between 2,000 meters and 6,000 meters, can be either all liquid or a mixture of liquid and ice crystals. This is due to the cooler temperatures generally present at the heights at which these clouds form. Middle clouds are usually layered. Altocumulus clouds often resemble white fish scales. Altostratus clouds are dark but thin veils of clouds that sometimes produce mild precipitation. High clouds. Because they form above heights of 6,000 meters, where temperatures are below freezing, high clouds are made up of ice crystals. Thus, some, such as cirrus clouds, often have a wispy, indistinct appearance. Another type of cirriform cloud, called a cirrostratus, forms as a continuous layer that sometimes covers the sky. Cirrostratus clouds can vary in thickness from being almost transparent to being dense enough to block out the sun or moon. Clouds of vertical development. If the air that makes up a cumulus cloud is unstable enough, the cloud will be warmer than the surface or surrounding air and will continue to grow. As it rises, water vapor condenses, and the air receives additional warmth from the release of latent heat. The cloud can grow through middle altitudes as a towering cumulus. If conditions are right, it can reach nearly 18,000 meters. Its top is then composed of ice crystals. Strong winds can spread it into a familiar anvil shape. A puffy white cumulus cloud can thus develop into a full-fledged cumulonimbus. What began as a small mass of moist air is now an atmospheric giant, capable of producing the torrential rains and strong winds that are characteristic of thunderstorms.
Precipitation. All forms of water that fall from clouds to the ground are precipitation. Rain, snow, sleet, and hail are the four main types of precipitation. Clouds contain water droplets that are so small that the upward movement of air in the cloud can keep the droplets from falling. In order for these droplets to become heavy enough to fall, their size must increase by 50 to 100 times. Coalescence. One way that cloud droplets can increase in size is by coalescence. In a warm cloud, coalescence is the primary process responsible for the formation of precipitation. Coalescence occurs when cloud droplets collide and join together to form a larger droplet. These collisions occur as larger droplets fall and collide with smaller droplets. As the process continues, the droplets eventually become too heavy to remain suspended in the cloud and fall to Earth as precipitation. Rain is precipitation that reaches Earth's surface as a liquid. Raindrops typically have diameters between 0.5 millimeter and 5 millimeters. Snow, sleet, and hail. The type of precipitation that reaches Earth depends on the vertical variation of temperature in the atmosphere. In cold clouds, where the air temperature is far below freezing, ice crystals can form that finally fall to the ground as snow. Sometimes, even if ice crystals form in a cloud, they can reach the ground as rain if they fall through air warmer than 0 degrees Celsius and melt. In some cases, air currents in a cloud can cause cloud droplets to move up and down through freezing and non-freezing air, forming ice pellets that fall to the ground as sleet. Sleet can also occur when raindrops freeze as they fall through freezing air near the surface. If the up and down motion in a cloud is especially strong and occurs over large stretches of the atmosphere, large ice pellets known as hail can form. Figure 1122 shows a sample of hail. Most hailstones are smaller in diameter than a dime, but some stones have been found to weigh more than 0.5 kilogram. Larger stones are often produced during severe thunderstorms.
Figure 22. Hail is precipitation in the form of balls or lumps of ice that is produced by intense thunderstorms. How might the layers in the cross-section of the hailstorm form?
The water cycle. More than 97% of Earth's water is in the oceans. At any one time, only a small percentage of water is present in the atmosphere. Still, this water is vitally important because, as it continually moves between the atmosphere and Earth's surface, it nourishes living things. The constant movement of water between the atmosphere and Earth's surface is known as the water cycle. The water cycle is summarized in Figure 1123. Radiation from the sun causes liquid water to evaporate. Water evaporates from lakes, streams, and oceans and rises into Earth's atmosphere. As water vapor rises, it cools and condenses to form clouds. Water droplets combine to form larger drops that fall to Earth as precipitation. This water soaks into the ground and enters lakes, streams, and oceans, or it falls directly into bodies of water and eventually evaporates, continuing the water cycle.
Clouds are formed as warm, moist air is forced upwards, expands, and cools. Air mass is stable if it tends to return to its original height after it starts rising. Cloud droplets form when water vapor is cooled to the dew point and condenses on condensation nuclei. Clouds are classified by their shapes and the altitudes at which they form. Cloud droplets collide and coalesce into larger droplets that can fall into Earth as rain, snow, sleet, or hail.